I'll start, I'll make a slight introduction and then we can proceed. Right. Thank you. So, good evening, ladies and gentlemen, and welcome to our first training session on IoT. My name is Ishan Bugali and I'll be your host for the evening. It is indeed an immense pleasure to see how many people are joining this workshop, and I'm sure that you will have a fruitful session with us and enjoy this evening's presentation. This event is being organized by the IEEE student branch, and hence I would like to invite Mr. Hemkesh Nirmal, the chairperson of the IEEE student branch, to introduce you to our organization. Hemkesh, you may proceed. Hemkesh, are you there? We can't hear you, Hemkesh, if you are talking. Can you just check your microphone?
Yes, Sean, it's okay now?
Yeah, we can hear you. Good, you may proceed.
Yes. Okay, thank you, Sean. Mr. Murdan, and everyone present, good evening. As Sean mentioned, my name is Hemkesh Nirmal, and I am the chairperson of the IEEE UOM student branch. So many of you might be wondering, what is IEEE? IEEE is the Institute of Electrical and Electronics Engineers, and it is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. IEEE and its members inspire a global, inclusive community through its highly cited publications, conferences, technology standards, and professional and educational activities. The IEEE is categorized in different sections, and in Mauritius we have the Mauritius section, in which Mr. Merdan himself is a member and is an executive member on the board. And under the Mauritius section, we have the student branches, namely the University of Mauritius student branch, the University of Technology Mauritius student branch, and most recently, the Middlesex University student branch. At our student branch, we strive to promote STEM, that is science, technology, engineering, and mathematics, in order to help students throughout their journey. Within our branch, we promote teamwork and personal growth. We do so by organizing webinars, seminars, competitions, and community outreach. For instance, on the occasion of Women in Engineering Day, we went to an all-girl high school and shared our experience as students and invited people from the engineering industry to talk about their experience also. We also showcase simple original projects to help get more students interested in science and technology. At our branch, we give the opportunity to students to really express themselves through ideas, innovations, and even proposals that they come up with. As I mentioned earlier, personal growth, anybody that wishes to attend something like public speaking or even helping organizing an event or even take the lead to organize an event like this one, uh, we always encourage them and also give them the guidance and encouragement that they need so as they are able to grow as an individual and grow as part of a team. On an ending note, I would like to invite all of you to join our little family and wish you all the best for the upcoming competition. I would also like to take this opportunity to thank Mr. Murdan for being our resource person today, and today's session will be an interesting one. For any queries about IEEE, you may contact myself or any other exec members within our branch. I will leave my contact details and coordinates in the chat box. Thank you for your attention.
Yes, thank you, MKH, for introducing our organization. And indeed, the IEEE student branch is trying to innovate, and we are proud to present to you our new competition with the theme Design and Implement a Smart Farming System. What is it, you ask? It is simply a competition based on the use of IoT and Arduino, whereby participants will be asked to apply different agricultural techniques to make a smart farming system on their own. It is open to all undergraduate students and even those who are not in the technical field. If you feel like you lack knowledge in this particular field and don't feel confident enough to participate, don't worry, we got you covered with free training sessions. The first one, being this evening, is on IoT. The second one, on the 10th of October, will be on Arduino and the use of simulation softwares that will help you use the device. And the third one will be on the 17th of October, which will be on agricultural techniques and how to implement them. We will also create a Google Classroom after this session where additional materials will be shared. Hence, after all of this, you will get enough knowledge and resources that will allow you to implement a fully functional system based on the title above. Now, if you want to participate, it's simple. Just build your team of 3 persons maximum and start working on your design as soon as possible. We have set a deadline on the 32nd of October for each team to submit a written proposal of their design. And then our panel of judges will analyze each and select only the eight best ones. Then these 8 selected teams will have to come to the engineering tower on the 27th and 28th of October to implement and build their projects. At the end of their last competition day, our judges will assess each project and announce the top 3 of the competition. We will communicate the prices for the top 3 soon. Please note that certificates will be awarded to the winners, that is the 8 best teams that will be selected, and it will also be awarded, e-certificates will also be awarded to those who attend all 3 training sessions. Unfortunately, I must emphasize that this competition is open only to undergrad students to keep it fair. However, our training sessions and Google Classroom are open to anyone who wishes to attend and learn new stuff. I guess I have covered it all. Sorry for it being so long, but I had to cover a lot of things. And if you have any questions and you want to participate but don't have a team, feel free to contact us, as Hamkesh mentioned earlier, via the numbers on the posters or through our social media. Now, I guess I've covered it all. Moving on to this evening's session, as I mentioned earlier, it is on IoT, short for Internet of Things. We will explore the key concepts of IoT and how it is implemented. To enlighten us about this topic, we have with us Mr. Anshu Madan. Mr. Madan is a much appreciated senior lecturer at the University of Mauritius and an executive member of IEEE Mauritius section, as mentioned by Hamkesh earlier. He is really experienced in the field of IoT, having delivered several talks on the topic in the past, making him the best suited person for today. Having attended them myself, I can vouch for that. He will deliver his presentation and it will be followed by a Q&A session. Mr. Madan, are you ready, sir?
Yes, okay.
Yes, thank you, sir. You may proceed.
Thank you, Zishan, and thank you, Hamkesh. I just share. Can you see me?
Yes, we can see you.
I can't see myself.
Sorry?
Give me 1 minute.
No problem.
Okay. Good evening, students. Today's talk will be on IoT, so Internet of Things. And I hope you might have heard this term, and a few of you are already very much aware of what this Internet of Things is, right? So let me share my screen. Yeah. Can you see the screen?
Yes, sir.
Yeah. Okay. So won't be quite long, because if you want to cover Internet of Things, the whole topic, you might need, it can be a module itself, right? So as Zishan mentioned, so this is one of the topics, one of the talks. So there will be 3 in total. So today I'll just cover one part of it, that is the Internet of Things. And there will be another one on microcontrollers and another one more focused on agriculture, right? So let's start. We'll try to see in this session, right? We'll try to have just an overview of what is the Internet of Things, what does the phrase Internet of Things mean, and how does it relate to the buzzword that came before this, that was known as ubiquitous computing. When you talk about Internet of Things, there are 2 words there. There's Internet and there is things. So where does it sit in the broad sweep of things? And also, why are we talking about it now, right? So we'll try to answer these questions, and then of course we'll take as applications of IoT, and also a few applications in the agricultural field. So what is Internet of Things? Today, it is currently creating a buzz. Everyone is talking about this, but you have to know that it was coined. Give me 1 minute. Yes, everyone is talking about Internet of Things today, but the term was coined by Ashton Kevin in 1999, so almost 22 years back, 23 years back, right? And he then said that the IoT has the potential to change the world, just as the Internet did, maybe even more so, which means by this time, in the early 2000s or 1999, Internet was already there, right? And it had already created a big buzz, right? So this is something that was coined 2 decades earlier. And of course, over time, Internet grew. And of course, the Internet of Things grew. So we'll see how, right? So today, there's considerable promotion and hype, and almost inflated in expectations. Some people are talking about this as a strategic technology trend, a mega trend, a game changer that will cause significant impact, a $1 trillion market, and the next boom, right? Next big thing. So how did the Internet evolve, right? Internet evolution is continuous. It's going on. In the 25 years, the Internet has grown to link billions of people through computers, mobile phones, through computers, right? And mobile phones. This is repeated here. Now the Internet is being used to connect various objects, such as cars, sensors, controllers, TVs, machinery, transport containers, electrical appliances. So all this is Internet of Things, right? The difference between Internet, well, as we know it, you are going to connect to the Internet. We say we connect to the web, right? So you connect to the web through your mobile phones, through your PC, tablets, or laptops. So this is Internet. When you connect objects or things, objects can be a car, can be a sensor, controller, can be a TV, machinery, right? So this is Internet of Things. Now, over time, there have been several names that have been given to it. Some companies call it Internet of Everything, or the Web of Things, or machine-to-machine communications. So this is still there. Today we call machine-to-machine communication M2M, or even IIoT, Industrial IoT. for the Internet of Everything. Now, this was coined by Cisco, Internet of Everything, which is still there, but then the term IoT, Internet of Things, is more common. And of course, the industrial IoT, this is taking, this is the right thing now. Today, it's happening in big industries, right? So this is a simple thing that shows the Internet of Things: connectivity, sensors that call emergency services if elder people falls, sensors in factory floors to control equipment, centralized monitoring street lighting, water mains, air conditioning, elevators notifying fault. So what you see here, printers alerting that ink needs replacement. What you see here, these are all objects that long ago, well, even today, you have tons and tons of objects in your house that are sort of dumb. Dumb means not smart, right? They perform as objects, right? They cannot communicate. But Internet of Things give these dumb objects the ability to communicate and communicate over the internet. Then you can be at a distance, right? You don't need to be there. You can get notification, right? Or you can get control signals on your mobile phone. So this is IoT, right? So let's see a few definitions, right? Now you have very many definitions from Gartner, IEEE, EU, IERC, and very big standards companies like IEEE. So most of them, they say almost the same thing, right? Let's take this definition from IEEE, right? What it says? It says an IoT system is a network of networks, right? So this is important, is a network of networks where typically a massive number of objects, things, sensors or devices are connected through communications and information infrastructure to provide value-added services. So this is very important. If you're doing an IoT system, you have to think in terms of this. What value is being given, right? Through intelligent data processing. Of course, you have data processing and manager for different applications. Now, what are different applications? It can be smart cities, smart health, smart grid, smart home, smart transportation, smart, everything that's smart, right? They fall in the IoT, right? Which means they can communicate. They can give you an indication of their state, of their current state, right? So this is one definition that covers everything, right? Now, the Internet of Things, the Internet. In Internet of Things, you have Internet. The Internet is used to send, receive, or communicate. You need some medium to communicate. So this is the role of the Internet. And the thing is the gadget to it is connected, right? The gadget that's connected to it, note that the thing, when you talk about a thing, it is not the computer, tablet, or mobile phones, right? Because these devices, computer, tablet, and mobile, they are already intelligent, right? We are talking about an object, the thing. Like in this one, you see the car, the thing, the bulb, the machine, washing machine, the thing, camera, the ship, the micro oven, right? Microwave, right? These can push to the internet, right? Push the notifications, printers, right? These are the things that we're talking about. And you have massive number of these things in your house or in industries or everywhere, right? So the basic thing to remember here, when you talk of Internet of Things, you are trying to make objects that were initially dumb, you are making them smart. While making them smart, you can make them sense and communicate. By communication, you can also say, okay, notification of the current states. If there's a fault, it will notify you the fault. So it has the ability to communicate a piece of information, right? Okay. So the basic idea is that rather than having a small number of very powerful devices, in your homes, you can have a laptop, a tablet, a phone, music player, right? But this is always limited. You can have maybe 2 phones, 3 phones, 1 tablet, 2 tablets, 1 PC. So maybe you have 10 of these devices, right? But you might also have a large number of devices which are perhaps less powerful, much less powerful. Umbrella, bracelet, mirror, fridge, shoes, all these are objects, right? The idea of Internet of Things, you make these objects become smart. You connect all these to the internet, and they can provide value-added services. Now you can say, okay, what value-added services can these provide? Let's say an umbrella, for example. An umbrella, the basic function of this object, let's say this is a thing. Umbrella is a thing. What is the basic function? The basic function is you cover yourself. There is sunlight, there is rain, you cover yourself with the umbrella, right? But then how can you add value? Suppose there's an old person that walks around with an umbrella, but then you say, okay, if I knew where he's going, or you want to track this old person for his own safety, right? You can put a small GPS in the umbrella, right? And the umbrella becomes you can track the GPS. So this becomes a smart object. Same thing for the bracelet. You can put a GPS. So you can track someone. The mirror, you have smart mirrors today that can be connected to your account that gives notifications. Fridge, you have smart fridges. These are common now, right? You have very many companies, Samsung, LG, everyone. They have smart fridges. So fridge, they can tell you, the fridge can communicate to you. Okay, so this vegetable is missing. So there are various things that you can, various functionality that can give the fridge. Now the shoes, even the shoes, you can put a GPS, right? We're not saying spying here, but you can say tracking. You can track a child who has gone for a picnic, or you can track an old person who might get lost. So you're making all these objects become smart. So you're adding value, right? So this is the idea of Internet of Things, right? Now, earlier you have this term ubiquitous computing, same concept, and reflect huge number of possible objects that contain computing technology. Ubiquitous, which are everywhere, all the time, right? So computing is made to appear anytime and everywhere, right? So in contrast with desktop computing, ubiquitous can occur in any device, any location, any format, right? Also known as pervasive computing or ambient intelligence, or everywhere. You know, where you have hardware, software, firmware, and now you have everywhere. So this means anytime, anywhere, everywhere, any device, any location, right? So this is ubiquitous computing. Now, very fast, why people are actually using IoT, right? Now, early days, IoT, much of the focus was on industrial applications, M2M, right? Improve of autonomous machines, so standalone consumer products. Today, you see there is much more human-centric category. Is smart is of IoT, but is starting to emerge. What this means? It's not necessarily automation, but it's personal augmentation. What this term means is less about devices, more about living services, right? People are using IoT to connect their smart devices, and what they want? What is the added value? The added value, let's see in an open source analysis of IoT user behavior. So analysis was conducted, and so many people were interviewed. And this was carried out by Harvard Business Review, which is a very much, it's an authority in itself, right? So people want IoT that provides personalized services. that can be adapted to different contexts. As with industrial IoT, the human IoT promises to be transformative. Now, why? The question is, why do people use IoT? Right? What do they want? So many people were interviewed, and the results were like this. Most people, they want IoT systems for extending security. Now, security is very important, right? Initially, you had CCTV. Now you have CCTV, but then much more IP cameras, and instead of DVRs, you have NVRs, right? And today the cameras are more intelligent, or even more intelligent than before, so they can sort of recognize face recognition, and also send the data over the internet to your phone. So this is security. People are sort of very much security conscious. And then quantifying the self. Quantify the self. The self means yourself, human body. So this is also very important because people are becoming more aware of their own self, body. So you have very many wearables that have come out, right? Wearables in the form of watch, bracelets, whereby it can give you your heart rate, heartbeat, even the pulse rate. It can give you the some of more advanced functions. What is the distance you walked, how many steps you made, right? All the things. You are quantifying yourself. And then optimizing machines. So you have a machine, right? You have become slightly lazy, so you want it to be automatic, but then more than automatic. Automatic, yes, but also gives you sort of a notification when it starts, when it finishes. And finally, enhanced experience. Well, enhanced experience comes here last. Why? Because you need all this first, then you enhance your experience. This is sort of you come in your car, right? As soon as you come in front of your gate, you have a camera. The camera recognizes the car, the gate opens, you enter. As you are entering your house, your yard, you see lights lighting up automatically. So this is enhanced experience. You can open your door. As soon as you open the door, you get a welcome message. You get your favorite music on. So this is sort of enhancing experience, right? So people want this also. You have a niche market for this as well, right? With IoT, you can do all this, right? But before doing this, you need to extend security, self, and all this. So today, IoT is being used for this. Technologies that extend security, apps that quantify self, the optimization of machines, and then enhancing daily experiences. So this is for IoT, right? Now, how does it work, right? Right, how does it work? Broadly, so this is just summarizing, right? You have four main components of an IoT system. You have the thing itself, the device, right? Be it a chair, be it a gate, be it a table, right? Be it an umbrella, these are things. Then you have the local network. This can include the gateway, which translates proprietary protocols to the IP, Internet Protocol. So maybe you have an umbrella, whereby you have connected a GPS, and you need a link to push this GPS message on the internet, right? So you might need a SIM card, right? Or if you're inside the house, the local network is your Wi-Fi, right? Or if you're traveling, if you are now today, you have Wi-Fi, you have cellular communications, you have LoRa. LoRa is taking up. You have Sigfox, right? So you have so many local networks that can have, and then you have the internet. So the local network just translates the proprietary communication protocol onto the internet. So the message has to pass through the internet normally, because say your house is here, You want to monitor the temperature of the house, or you want to monitor your gate, right? And you are abroad. So how will you get the message? It has to go through the local network and then the internet. Now, you also need these backend services, enterprise data services, or PCs or mobile devices. This is important. This is normally on the cloud, right? Then you will get whatever you want from this to your mobile, right? Let's see pictorially. You have the thing. So the thing, normally, to make it intelligent, you have to put a sensor there. Suppose you want your house to become slightly more intelligent, you put a temperature sensor. So this is a sensor. It will measure temperature every minute and then send you. But then you need a processor as well, right? Processor. In IoT, you have microprocessors and microcontrollers. You don't use computers. In computer, in fact, you have a microprocessor there, right? So to measure temperature, you won't put a computer, right? You put a small microcontroller. And then communication. So this thing has become intelligent with the addition of sensor and actuator. In fact, sensor, it senses, actuator, it does the work, it does the action, right? So when you are sensing temperature, if it is too warm, then you activate the fan or the aircon. So the fan or the AC, aircon, becomes the actuator. The sensor is the temperature sensor. Processor can be a small microcontroller, or the Arduino, or any other family of microprocessors. You have many more, right? The communication can be Wi-Fi, say in your house. So it communicates with this. Now, gateway is optional, right? You can have wired, wireless, power line, BN, PN, LAN, personal area network, and then BN, right? Body area network, right? So this is body area network. This is personal area network, like Bluetooth. Can go up to maybe 5 meters, 6 meters. That's it. LAN can go up to maybe 30 meters in line of sight. Otherwise, it can go up to maybe 15 meters. It pushes the data to the internet. And on the internet, you have normally the cloud. These are backend services, right? You have the cloud server, right? The internet and the cloud, they are used synonymously, right? So you have the cloud server, can be a remote server. Now, from here, the intelligence is here as well, because you need to have a big database, so you're sending information every minute. You have a big database, but it's located in the cloud, right? And then user access, whatever you're accessing, it comes from the cloud, because this may be in your house in Mauritius, and you are abroad. You get all this information from this server. But today, the cloud platforms have become very much more intelligent. They have business data analytics, what we call analytics. You can call it data analytics. You can call it business analytics, right? So just brief on the clouds. So the Internet of Things is about connecting, what is it? Internet-enabled devices that relay information back to cloud-based applications, right? So this is very important. Today, in most of the IT solutions, you think about cloud. But then suppose you are working in a very secure environment and you don't want to send your information on the cloud. You can have a private server, right? So you can host everything locally, right? Instead of pushing on the cloud. So this is possible. Now, these platforms connect sensors and data networks to one another, integrating back-end applications to provide insight into large volumes of data. So this is analytics. You're capturing temperature data every maybe 10 seconds, or say every minute. In 24 hours, you have already captured 60 fois 60, right? Over a month, you already have huge amount of data. So this huge volume of data, for people to get insights is difficult. So these platforms have analytics that do the trend. They find trends in the data. So they can process huge volume of data and find trends and provide insights, right? So UPS business with IoT networks can trigger push notification automatically when the device comes in contact with the particular sensor, right? So analytics is really important. Today, it's difficult to imagine IoT solution that doesn't rely on cloud, right? Most of them you have to push on cloud, and cloud, there you can get some insights. So this is like this. Device, connectivity, any connectivity, can be Wi-Fi, it can be 4G, 5G, 3G, 4G, 5G. It can be access point. You can have a gateway, LoRa gateway. It goes on cloud. Here the rules engine, storage, and these are protocols. And then they can push data to the application. They can pull data as well, right? And they can notify the people. So this is a brief, right, about the cloud, about the IT platforms. Now you have very many names, big names that you might have heard. You have Azure, you have Bluemix, IBM, you have Intel, Apple, Google, Cisco, Oracle, AWS. All the big names are there, and you have many more. As at today, you have more than 600. Yeah, so this comes from IoT Analytics. 2015, 2021, there have been around 616. Last year, there were 13 cloud platforms, right? You have very many more. Some come and then they vanish, right? But the big names are there, right? Okay, so now we'll just touch on IoT in agriculture, because as I said, this first talk is only about IoT. And there will be 2 more talks that will be on microcontrollers, and another one will just focus on agriculture. So I give you a brief overview of what was the Internet of Things, how it works, how you can think about it, right? And now one of the it has applications everywhere, right? So one of the most important applications is in agriculture. So just looking at this, you can see, okay, this is a field, you have auto spreading, you have diagnosis of diseases, you have crop yield analysis, you have smart data, soil erosion, field monitoring, variable rate of fertility, water stress. You have so many things that you can do in your fields, right? You go to our crop management, right? So all this can use IoT, right? All these applications are real applications that have already been installed and they are working fine. They are facilitating the lives of farmers. So just a few slides on agriculture. So recent statistics say that global population will reach around 9.6 billion by 2050, right? So we are not that far, and the population growth will be here. So governments have to cater for food, right? Now catering for food, you have now challenges that were not there earlier. Today you have extreme weather conditions, avec réchauffement de la planète, right? You have extreme climatic changes, environmental impacts. You saw the Japan, there was this big cyclone that never get there. That big cyclone in Pakistan, you have floods that were never happened before. So day by day, you have extreme conditions that can affect all the crops and destroy all the plantations, right? So these are very big challenges. Now, in the past, till the late 20th century, right, you had a lot of mechanical innovations that helped planters for farming. So these were many of these tractors, harvesters, all this mechanical. But in the next several years, there is a use of smart solutions powered by IoT will increase in the agricultural operations. It's already happening, and it will happen in larger scales. And reports say that IoT device installation will see a compound annual growth rate of 20% in the agricultural sector. So we were talking about a sector that was traditionally not intelligent at all. We have seen mechanical innovations. Now we are seeing IoT innovations. Now, what are the applications? Very briefly, you have climate conditions. You can monitor climate conditions using sensors. You can go for precision farming. You can go for smart greenhouse, right? You can go for data analytics. You can go for agricultural tools. Now, this is a summary of very many things that you can do with IoT. We'll just take a few of these. So, monitoring climatic conditions. Today, farmers cannot just rely on meteo, right? Because meteo is it will give you for 1 day ahead, and it will give you temperature, give you rainfall, right? But then if you want to measure real-time weather conditions, meaning at every time you want to know what are the climatic conditions. So climatic conditions, it's not only temperature, it can be temperature, rainfall, humidity, pH of soil, and many others, right? Depending on the crop, right? So today, there's possibility to place all these sensors in your fields, right? And connect these sensors in an IoT ecosystem, and also send this information in real time over the internet, over the web, to a platform, right? And then do analytics, and then get insights, right? So this is climatic condition monitoring. We have very many projects that have been done in this field, right? This is quite common, right? And now we also have precision agriculture, or precision farming. So this is another term that this is quite new, that came out maybe around 10 years back or more recently. So here, the goal is to analyze the data generated via sensors and react accordingly. So you have various techniques like irrigation management, livestock management, vehicle tracking, many more that can play a vital role in increasing efficiency and effectiveness. So with the help of this precision farming, you can analyze soil conditions and other related parameters to increase operational efficiency, right? In precision farming also, you have, I know a few projects that are already working in Mauritius, right? And then you have smart greenhouse. Now, greenhouse was already there. Now you are smarting the greenhouse, right? Adoption of IoT in greenhouse, this has reduced the human intervention. We are trying to make the whole process cost-effective and increasing accuracy. So in greenhouse, you can put several sensors. These sensors collect and transmit information in real time, which will help in monitoring the greenhouse state precisely and in real time. Okay. You can also monitor the water consumption, greenhouse state, and all the information can be sent through emails and also SMS alerts. Can also enable smart irrigation, automatic irrigation with the help of IT. So this is already there. Now we are in Mauritius also, we see very many more greenhouses have been built in the last few years, and most of them are going for smart greenhouse. They want the information on everything, right? So this is something that is growing up very fast. Of course, data analytics. So this is everywhere. Whatever data you are sending to the cloud platform can give you the ability to do analysis. Now, depending if you're a small farmer, maybe you don't need this data analytics, but if you're a big planter, big farmer, then maybe this would be interesting, right? So basically what happens, the primary source, the sensors, which are primary source of collecting data at a large scale, all the data are analyzed and also transformed for meaningful information, right? So all sorts of analysis can be done with weather conditions, livestock condition, crop conditions, etc. Using predictive analysis, you can get an insight to make better decisions related to harvesting. Trend analysis helps farmers to know upcoming weather conditions and also harvesting of crops, right? Now, data analysis is not only in agriculture. You can say today, everything that produces data has to go through data analytics, right? This is a big thing in itself. And of course, if you are going for very large scale plantations, then you can have drones, agricultural drones. So this we are talking about very large countries, right? Whereby drones, they fly over the crop, they can take pictures, there's crop monitoring, planting, crop spraying, also field analysis. So they can also use thermal or multispectral sensors to identify areas that require irrigation. And once the crop starts growing, these sensors can indicate the health and also calculate the vegetation index. So this is for big countries, right? They're very costly. And also you have additional applications. You can have remote sensing for crop assessment, right? For soil quality. So remote sensing, there are more advanced features, right? You can use computer imaging using sensor cameras. So quality control, of course, we use AI and machine learning, sorting and grading, again, use machine learning, AI, and also mapping of irrigation lines, right? So these are additional applications. Now you have many more, right? But it depends on what you want, right? If you are sort of, if you're thinking about AI and also machine learning, cloud-based, right? Then maybe you are a big planter or a cooperative, right? But if you're a small planter, if you have a small greenhouse, then also you can cost effectively, you can have very low power and low cost sensors that give you information that would be useful for you. So the thing here I'm trying to explain, IoT caters for small businesses, even micro businesses, to very large businesses. And you can, everywhere you can be cost effective. It's not only for big companies, it's not only for small ones, it's for everyone, wide range. It depends on what you want, right? So with this, I will, I think I have taken more time. Yes, try to cover this. So if you have any questions, you can, yes, you can ask. So I think the organizing committee has already taken note of some of the questions. So yes, I will be answering your questions. Yes, Hemkesh is here, or Zishan, the questions?
Yes, sir. So I think we'll share, which way do you prefer? Do you prefer we share Google Doc and everyone send their questions in it, or do you think they can send them in the chat as well?
Okay, you can send it on chat. I think, okay, yeah, whichever way is easier. So I think they're already sending their mails to the co-host. So if you have any questions,
I'm just checking if they have any questions and read it to you.
Right.
So I got your first question. It is, to what extent is IoT currently being implemented in the agricultural field today? I think yes, you have covered some part of it.
Yeah. In fact, I know very many small businesses, small greenhouses, who were already, from the inception of the greenhouse, they're already putting IoT sensors there. So they know that the capital cost of a greenhouse is not extremely big. So in the capital cost, if they include the sensors and the information systems, right? They already know that what is the advantage. So it's already there, which I can assure you. In greenhouses, very many greenhouses, at least they can measure the temperature, they can measure the humidity, they can measure the pH, they can measure the what else? The temperature, humidity, soil, pH, and also the lighting level as well, which is important for some crops, right? This is already there, right? So, and in large businesses, I don't know very large businesses having implemented IoT solutions, but it is coming, right? You see, it is maybe we are hearing about IoT from maybe 10 years, right? So slowly it's taking up, and big businessmen, they want something that is already matured, right, to be able to implement it, because it's in big businesses it will be quite costly, right? Yes. So you have any other questions?
So yes, sir, I've got one. It is the government taking enough incentives to promote IoT in agricultural fields?
No, we can't say in agricultural field. Let's say it's general. Is the government taking initiatives to promote IoT itself? You have to promote IoT first, then you can say in agricultural field. Well, I know that in the last budget, there was a lot of incentives for planters. Well, I talk about the smart grid, let's say, right? Smart greenhouses. So but I know there are loans for greenhouses. If the person investing in a greenhouse, if he puts all these sensors and information systems in the greenhouse at the inception of the greenhouse, right? So in the capital cost. So of course it will be covered, and he will see that the amount of information he will get is value for money, right? Now, promotion of it's not only IoT; it's emerging technologies. We have a society, we have an agency in motion that provides. But earlier were called AI. AI it's under the Ministry of TEC, right? Now I think they will change their name for emerging technologies. Otherwise, you have AI, you have IoT, you have blockchain, you have very many. But I know they're working on this, right? The work is on, right? The questions?
Yes, sir. I'm just checking if I've got more questions. Just give me 1 second of review.
Okay.
So
we have today how many? 120 participants. Yeah, very good.
Yeah, we've got minutes to spend. So we are talking about assessing the soil quality and contents using technology. Has there been any research in which a specific method is used to analyze nutrients, and especially overuse of fertilizers, which might be harmful to human beings on the long term?
Yeah, this is very, very technical from the soil side, right? So I cannot answer this question, because even without the use of IoT, this is not IoT, right? If you're measuring the amount of pesticides, you're doing some soil tests. I know civil engineers do soil tests. Agricultural engineers also do soil tests for amount of chemicals in a soil sample, right? So this is not IoT, right? IoT, you put sensors like a pH sensor. You measure, the sensor will have the ability of measuring the pH and sending it to a microcontroller, microprocessor connected to the sensor in an IoT ecosystem, and then send the information. So maybe there are sensors. I know there are smoke sensors for PM, particulate matter 0.05, 1.5, 2.5, so on. Maybe there are specific sensors for chemical content, but I will not be able to answer this, because I'm more in the ecosystem, not on specific sensors. Yes.
Sure, sir. I understand. Perhaps we will cover it more in the third session.
Yeah, in the third
Yeah.
session, whereby you get someone from agriculture.
Yeah.
Right. He might be able to answer what types of sensors are being used today. But if the sensor is there, we can connect it to an ecosystem, of course. This is okay.
Okay.
If the sensor is there, you can measure this, we can connect it.
Okay, so I've got another question. It says, how can we further optimize the IoT networks for more efficiency?
Now, when you talk of efficiency, right, we're talking about which type of efficiency? Maybe we're talking about efficiency in terms of energy usage, right? So very many of these solutions, they work with very low power, but low power is still power. If you put batteries there, the battery will drain. Suppose I put in an IoT system, I power it with the battery. Battery will, after some days, it will go down, right? But efficiency is always, whatever you do a solution, suppose it is outdoor or maybe even indoor, you can think of powering it using PVs, right? Photovoltaic modules, and also a battery. So we have done quite a few of these projects whereby during the conception itself, we calculate the amount of power, amount of electricity, amount of energy will be used, and we size the PV panels and also the battery. But it is slightly more costly. But then it will become autonomous. So whatever is autonomous is very sort of efficient, energy efficient, right? And also day after day, you're finding you get stronger microprocessors, more capable more processing power, right? And with lesser power usage. So this is the trend. Today, you can the microcontroller that you have today is maybe 100 times faster than what you had, say, 3 years back, right? And using the same amount of power.
Yeah, sure, sir. That's very good.
Yeah.
So I've got another question, if I can, if you have time for it.
Yes,
so there's a question where someone is saying, this is just an introduction to IoT and we need to explore more to be ready for the competition. So what resources do you advise us to go and search for?
You see, if you go on the web, you go on YouTube, you have tons and tons of resources, right? And second, it's a competition, because if we can have 10 sessions, right? Still, you will see, okay, some people will not be happy, right? This is only introduction. Of course, the participants have to do their own research. This is only introduction to the topic, but maybe some people, they don't know what is IoT. They have heard it here and there, but then I would say competitions are made so that the people self-learn. We are here to guide you, right? You self-learn and then go for it. Else, if we do 10 sessions, we already do the project for you, and then we say, what do we do now? Right?
Sure, sir. I can understand what you're saying. Let me just check if we have any more questions, and I'll get back to you.
Yeah, maybe is it possible to open the flow so that we can take a few questions directly from the participants? Is it possible?
Yeah, sure. I will just tell my friend Manvir to do it.
Yeah. We can take a few just from directly. So
they can send it in the chat, sir. Yeah. The chat, or if they want to talk, or is it better in the chat?
Yeah.
So if anyone has any question, you may send it in the chat to Mr. Madan himself, or you can send it to everyone so that we can all see the questions.
Okay, I have a question right now. Okay, yeah, it's right now. How can we as students help in agriculture IoT systems design? Right. Now let me answer this question. Now, when you say help in agriculture IoT system designs, most of the time, as students, you have to come up with a proof of concept. Proof of concept means you can construct a mini or even a micro, maybe greenhouse, whereby you can show. Proof of concept means you are showing that these sensors are performing, they are capturing the data, and you have a small communication system that is pushing it on the cloud. So you can use a very small scale. Once you show that it works, then you go for larger designs. So I would advise you to go, instead of going on a field, go for proof of concepts first. You understand how it works, and then you can promote this. You can do it in your own house, you can do it in your own garden, right? So once the thing has to work, so this is proof of concept. Now, farmers such as breed, I got the, okay, looking at the questions. What are the challenges the agricultural field is facing that the projects are based? Now, this is, you have to find out. What are the challenges the agricultural field is facing so that the projects are based in solving these problems? You have tons and tons of problems. You have tons and tons of challenges that farmers are facing. So your role is to go and talk to these farmers and see, right? Some people are interested in irrigation of their fields, right? Irrigation, that's already there, that has been mechanized, right? Sometimes the amount of water that you want to irrigate depends from crop to crop. So is it possible to use the same system? Suppose I'm talking about overhead or even drip irrigation. Is it possible to use the same system for different crops? Some crops need more water, some less water. So this is an application of IoT. Yes, with IoT, you can put a pump, you can control the amount of water using the same infrastructure. So you have very many problems like this. You can talk to farmers. Okay, we have another question from Azo Virginie. Facing the situation of shortage on some crops, even importing problems will be too many things. So wait, let me read this first. Will it be more efficient to invest in making programs to introduce IoT around the island? This will be to increase, yes, of course, crop efficiency quality. This is interesting. But normally, again, what I told you, I already answered this question earlier. If you want to do something, do it small scale, very small scale, right? Make a proof of concept, make it work. Use your sensors, actuators, your mobile phone, use all the things, and then you can show that it works, right? And then you can make a program, but you have to make the thing work first. Yeah, another question. Is IoT a future in Mauritius, bearing in mind with much more reluctancy in technology adaptation, cost factor surveys, more elderly people? Yes, you can. Now, this is a more general question. The question is about reluctance to adoption of technology, not adaptation, adoption. You have old people or much more elderly people in agriculture, but this is only one. I know very many youngsters today, they're going for smart greenhouses and they want to put everything high-tech there, right? So this is changing. The older generation, which is already there, they may not adopt it, but if you can do something, a proof of concept, and then you can demonstrate to these people, well, they will adopt. And also the reluctance in technology adoption is there. It's already been there. When the fields were mechanized, even then people were reluctant. Yeah, we'll lose jobs. What will we do? Why are you mechanizing the field? So it's already there. The mindset's already there, but it's changing because newer generation are more open to adopting technology. Yes, you have a question from Vanen. Challenges: we have pest, water, light, ammonia level, etc. Yes. So these are challenges. Try to find how you can find solution to the challenges using IoT, using sensors. Omkar is saying, when more should you recommend can the public in general purchase IoT in context? Now, you have these sensors very many places. I will not mention, but you have some electronic shops specialized in motion, wherever you can get all this. But then most often, if you buy directly from eBay, AliExpress, you can get things there, right? So if it's not available in Mauritius, it will be available abroad, right? Yes, we take maybe 2 last questions.
Okay, sir. Which question would you prefer to take?
Okay, breeder. To which extent can IoT help a breeder? Now, what is breeder? What is you want to say chicken breeder? Cow breeder. Okay. Now, if you're a chicken breeder, your challenges are different. If your cow breeder is different. You have to find what are the problems, and you have to meet these people, right? Sometimes in Mauritius, I don't know, you have very many cows in Mauritius, number of cows per breeder. You have to find this. Say in big countries like New Zealand, you have one breeder can have maybe 10,000 cows. Then they have GPS systems on each and every cow. But if you have 2 or 3 cows, I don't know, GPS is a big solution, right? I don't think it will be a solution, and it depends on the range of the yard where they are breeding, right? What is the size of it? Will they be lost, right? So this depends on the context, right? If you're a chicken breeder, now it is different. I know there was a project whereby there was automatic counting of eggs, and also with IoT, with the specific cameras, you can also detect whether the egg was good or bad, right? So this has already been done, right? Right, image processing. Okay. When you mention organic product, does it mean that they use IoT to better create a better quality product? No, I don't understand this question. Question from Levin. When you mention organic product, does it mention? No, IoT, you can't create a better product. IoT, c'est pas magique, ça, hein? No. The product stays the same. You take the product parameters, you send over the cloud, over the internet to a cloud-based system, which will give you notifications. This is IoT. You can't take a product, make it better. No. Especially organic product, no. Some electronic shops, yeah, you have many electronic shops I don't want to mention because I don't work for these guys. You might get the impression that, okay, I'm favoring this. You have very many electronic shops in Mauritius, so you go and find out. We already have microchip in cars. Can we use it for monitoring the health? Yeah. Now, it depends on what the microchip does. You can have a microchip in a car just for GPS. You can have another microchip in the car just for a number of steps he has walked. But health, maybe there are. Like for humans, you have you can have watch to measure the heart rate, but maybe for the car also you have I'm not aware of this, but maybe you have all this. right? You just have to search for it. Okay. Yes, Zishan, we can.
I guess we have covered most of the questions, right, sir?
Yeah.
So I just want to post some announcements concerning the competition. For those who want to participate in the competition, we will share a link with you in the chat so that you will be able to join the Google Classroom that we have created for this competition. This Google Classroom will be a place where additional materials will be shared, and also those who want to participate needs to be on it. If ever you want to participate but you don't have a team, please join the Google Classroom and contact us, and we will try to assign you to a team that is going to participate. And also, we will share with you all the links to today's recording. And as a gentle reminder, please feel free to also fill the attendance form. Now, make sure that you don't miss our next session on the 10th of October. We will share with you how to use simple simulation softwares, and such as Tinkercad, and also how to use an Arduino for automation. If you have never done it before, you won't believe how easy it is. So don't miss it. I guess that's true what I'm saying, sir. Correct? It's very easy to automate things.
Once you start with it, you say, okay, why haven't you started earlier? It's so easy.
Exactly. So yeah, again, I urge you all to join the Google Classroom if you want to participate in the competition. And even if you don't have a team, don't worry, we will try our best to find you one. Also, another announcement that I need to make is, please start forming your teams. And I urge you all to start researching and working on your design proposals. Since we have set a deadline for the 22nd of October, I will say that it's only around 20 days away, so it's not a lot of time. Make sure you research it as much as possible so that you get the best chance possible to win the top prize. I guess that's all for today. At this closing instance, I would like to thank you very much, Mr. Madan, for this first session and for taking some time out for us. If you have any last thing you want to add, sir, please feel free.
Thank you, Zishan. Thank you, Hamkesh. Thank you, the team, the organizing team. It's a very laudable initiative from the part of the IEEE student branch. We know that you have been doing quite a lot of things, helping students learn on their own, helping them progress, organize competitions. So this is a very, very laudable initiative, and thank you very much. Right.
Thank you, sir, for these encouraging words. It really means a lot to us. And another thing I forgot to mention is, don't worry, we will share everything about the competition to you, the rules, the prices, and the devices that we'll be using in the coming week. So don't worry about that. We will email you about all this stuff. So on this note, some people are saying that they can't access the Google Classroom. I guess we just haven't completely opened it yet. I will just check with my friends if everything's okay, and I'll let you know in a second. Oh, so yes, you will need to use your Umail to enter the Google Classroom. Yes. For those who are not able to attend the Google Classroom, you need to use your Umail, I think.
No, Sean, it's not your mail. Use your personal mail because we are having some trouble with the Umail, etc.
Okay, don't worry.
Use your personal mail to join the Google Classroom. Also, I would like to thank Mr. Murdan again for his participation today as our resource person. And thank you, sir.
Thank you, Hamkesh. Thank you, everyone, for your attendance.
Thank you, sir. So yeah, just use your personal mails, and if ever you're having difficulties, don't worry, just come and contact one of us, and we will try to make sure that you are able to enter the classroom. So thank you, sir, once again, and have a good evening, and bon appétit, everyone.